types of rocks in mining geology. After that, we have seen how igneous rocks have been formed. Before igneous rock formation, we have seen how the rock cycle which transfers from one rock to another rock and what are the categories of rocks, and I have given some examples on it. Today, I'm just planning to give you about the rocks on sedimentary, how sedimentary rock have been formed and what are the process of forming the sedimentary rocks, how are they classified, and what is the use of sedimentary rocks. It's going to be a video lecture session. I will be giving a small hint at first. After that, it will be a video. I think there are four videos today you're going to see. It will explain elaborately about the formation, types, common rocks, how they have been forming, origin to deposit, cementation, compactness, then grain size classification. All the things will be explaining by the video of today. Before I'm just going into the video, I just want you people to remind one another what we have seen. We have seen about the types of rocks. There are three types of rock. One is igneous, sedimentary, metamorphic. On igneous, the rocks which have been formed near the volcano, it is called igneous rocks. Example, granite. And second type, that is sedimentary rock, where origin at one place and deposit or settle at another place. That is sedimentary rock. Origin, it may be from igneous rocks or maybe from metamorphic rocks. So now we are going to see about the video lectures of the sedimentary rock. Now I am just going to share my screen. You people just see those videos and we will be having a question and answer session at the last. For that, first initially this 3 minutes video I am going to open and show you. If people watch this video and come back again, I am not going to give you the link. I'm just directly give you the video to see what it is about, what is the definition for sedimentary and what is the use of sedimentary. All those things you're going to see today. I think this is now.
I was walking my dog on the beach when I noticed that the cliffs are made of horizontal stripes of rock. But what causes this? To understand this, we need to explain how sediments are formed and explain how sediments are turned into layers of new rocks. Existing rocks can be broken down into small pieces or sediments in a process called weathering. There are three main types of weathering. Physical weathering is caused by temperature changes. For example, in freeze-thaw weathering, water gets into cracks in the rock. When the water freezes, it expands and forces the rock apart. This happens many times, eventually breaking the rock. An example of chemical weathering is when acid rain reacts with substances in rocks. Even plants or animals can break up rocks. This is biological weathering. The sediments formed by weathering can be moved away by water, ice, wind, or gravity. The combined process of weathering and transport is called erosion. Eventually, sediments settle in one place. For example, they may sink to the bottom of the sea. This is called deposition. More layers of sediment are deposited on top. Over millions of years, the weight of the layers above compress the ones below, and they harden into sedimentary rock in a process called compaction. Sometimes another substance seeps between the sediments and hardens, sticking or cementing the sediments together. The whole process leads to the formation of horizontal layers of sedimentary rock. So, erosion breaks old rocks into small pieces and transports the sediments. These are deposited in layers and compacted into sedimentary rocks. This explains the stripy appearance of the cliffs at the beach. Each stripe is a layer of sedimentary rock.
You have seen this video where that people they are explaining about how sedimentary rocks have been formed. Initially, the rock which have been present at the starting stage due to weathering effect, it will get broken down. Here, weathering are of three types. One is of physical weathering, second one is chemical weathering, third one is biological weathering. Physical weathering means due to rain, that is due to the effect of heat or cold. The rocks which are exposed to air, it will be having a contraction with the heat in the daytime and cold in the night time. It will expand and contrast and it will break at certain point of time. It will be a long process. So the part of rock will break for a more number of years and it will get broken down and settle down another region. That is physical weathering. Chemical weathering means if suppose a rain which have been falling in a particular place, due to the chemical content which have been floating in the air, the rainwater mixed with the chemical and becomes as an acid rain. It falls on the surface of the rock and rock react with those and making a chemical composition in it and makes the rocks to break down into smaller fragments. So that is chemical weathering. Then biological weathering means the growing of plants, trees, or some other thing in the land which erode the pot to for their growth. Then it will be becoming as an biological weathering. The while they have been breaking down the broken rocks which have to transport from there to the final stage. The transportation can be done by water, ice, and glacier. So, water, ice, glacier, for that purpose, they will be transporting the broken rocks and will be transported. So, this process, weathering and transportation, it comes under to erosion and deposition. In the video, they have shown about the deposition, where deposition means it will be a place where all the particles which have been eroded, it will be go and deposit in a particular region. In that they have been showing a layer by layer where today if suppose one content have been deposited on that area for more number of years, there are lots and lots of deposition will occur and it will be forming a layer, horizontal layers. Without any disturbance, it will be forming an horizontal layer. So by this, they will be forming more number of layers due to compaction. It will be get contracted one by one, binding each other, and squeezing will be happen. The content which are present in the deposition, it will be squeezed out. This is the first video what they have been told. Now we have been going to move on second video. Second video, you just hold on a second. I'm just going to open the second video. It is of about 3.36 of second, 3.6 minutes. Now you people go, I'm just going to share the screen. You just watch the video again and I'm just discussing about what they are telling and what we have seen on those videos.
What is a sedimentary rock, and what makes it unique when compared to other types of rocks? First off, we need to know what the other types of rocks are. There are three general classifications of rocks. First, sedimentary rocks. Second, metamorphic rocks. And third, igneous rocks. Each of these types of rocks has their own characteristics, their own ways that they're formed, and their own.
Here, he just explaining the order in a reverse manner. First, usually sedimentary rock will occur. Second, metamorphic rock will occur. Third, second sedimentary rock will occur. Third, only metamorphic rock occur. He just shuffled in his own manner and he is explaining those.
Ways to be identified. We're going to look at sedimentary rocks. Sedimentary rocks make up about 3/4 of all of the rocks on the Earth's surface. They also preserve a historic record of the environment at the time of their formation and are the only rocks that contain fossils. Sedimentary rocks are most often formed from pieces or chunks of other rocks. These pieces come in various sizes and are referred to as clasts. Sedimentary rocks can be made from mineral crystals and even organic material, such as bones, skeletons, shells, or even plants. All sedimentary rocks form through 5 basic steps. These are weathering, erosion, deposition, compaction, and lithification. Let's look at each of these steps individually. The first step is weathering. This is the breaking apart of larger rocks into smaller pieces that can eventually be reformed into sedimentary rocks. Weathering takes place in lots of ways. For example, wind, water, ice, or gravity, or a number of other forces cause rocks to break into smaller pieces. The next step is erosion. Erosion is the movement or transportation of the pieces or clasts of rocks. Again, there are lots of ways that rocks can be moved, such as wind, water, ice, or gravity. And these two steps, weathering and erosion, often take place at the same time. The third step in the process of forming a sedimentary rock is deposition. Each rock that's moving or being transported must come to a stop. This happens in deposition. This is where the clasts or pieces of rocks come to a rest on a surface. For example, this could happen on a riverbed, at the bottom of a rock slide, or where a river lets out into the ocean. Anytime a rock comes to rest or settles on the surface, it's known as deposition. Over the years, as more and more rocks or clasts are deposited, we get the fourth step, which is compaction. As these layers pile up, the rocks underneath become compacted closer and closer together. This removes a lot of the space that's between these pieces of rock. And this is done as more and more weight is layered on top of the rock. This brings us to our fifth and final step, which is lithification. Lithification takes place as minerals dissolved in water seeps into the spaces between rocks. These minerals work to cement or glue these clasts together. The process of cementing these rock pieces together is lithification. That describes the 5 processes required to make any sedimentary rock. Again, those are weathering, erosion, deposition, compaction, and lithification.
Here, he just explained about how sedimentary rocks are weathered, eroded, deposited, that is transported, deposited, cementation, then lithification. Likewise, each manner is just explained in a small hint where based on the climate it also an impact factor to creation of rocks of sedimentary from other rocks. Now we are going to move on to another video. I'm just giving you this video lecture what we are saying today in your MyCameo app. Today evening you will be getting the link. You can watch once again while you are free. I'm not giving you the YouTube video link because if suppose I give you YouTube link in your background, it will be having another run of those videos, so your data consumption will be more. So instead, I just downloaded these videos from the various websites and I have showing you the videos in evening time at today. You will be getting it definitely, or I will post the video link and I will let you know by intimating you people. Now we just going into another one video about the sedimentary rocks. Now I'm just going to share the screen again. The people get ready to watch another video and you will be gaining more info about the sedimentary rocks in our earth.
In this video, we're going to explore sedimentary rocks. We're going to learn what they are and the processes through which they form. We're going to start by looking at your reference table on the chart on page 7, which is called the Scheme for Sedimentary.
Here they have been explaining about the sedimentary rock identification in the field. How you going to identify is you first of all while you are entering the field, you can able to have a larger amount of rocks. In that basically I have told in the igneous rocks, if suppose you are finding on rock, you can able to see whether it is an igneous or sedimentary or metamorphic. Now you will find it out it is sedimentary. In that there are subcategories they will going to explain. You just listen. After finishing this class, you can able to differentiate somewhat whether it belongs to sedimentary. If it's sedimentary, what texture, based on the texture, what it will be. An assumption of giving the name could be done.
Rock identification. You'll notice that the chart is broken up into two sections. We have one section on the top and we have another section on the bottom. We're going to start by exploring the top part of the chart, which are rocks that are inorganic, land-derived. Now, inorganic means not living or never living. Land-derived means they come from land. So all of these rocks in the top section all come from existing land, basically rocks, that are not living and were never alive. You'll notice that in the texture column, all of these rocks are described as being clastic or fragmental. The word clast means pieces or fragments. These rocks are all made of pieces or fragments of other rocks. You'll notice the composition is the same for all of them. They're made mostly of quartz and feldspar. They have some clay in them, and they may contain fragments of other rocks or minerals. These clastic rocks are all created in a 5-step process, which I like to call the Wedkeke processes. This diagram shows you the Wedkeke processes. So let's start with the W, which stands for weathering. Okay. In order to get sediments, existing rocks have to be broken down. That process is called weathering. So think about land and think about rain and ice and wind and other processes that could break apart rocks and turn them into sediments. Okay, those are called weathering processes. Once the rocks are broken into sediments, they get carried in a process called erosion. They might be carried by water, by wind, by ice, glaciers, or sometimes just gravity, like a rock slide or a mudslide. Gravity just pulls the particles down. Usually they'll end up in water, and when they reach the bottom of the water, they will become deposited at the bottom. So that third step is called deposition, and that is when the particles become deposited, usually at the bottom of water. Now, over time, layer upon layer of sediments will squeeze down. They'll put pressure on the layers below them. And that pressure causes the sediments to become compacted. So compaction is the 4th step. Particles are squeezed together. And eventually, the minerals that are in the water will act like glue, and the particles will become cemented together. And that step is called cementation. So again, the Wedkeke processes: weathering, erosion, deposition, compaction, and cementation. In your reference table on page 6, you have a diagram showing you the rock cycle. If we look at a rock like an igneous rock, it shows us that if that rock goes through weathering, if it breaks apart, and if it becomes eroded and turned into sediments, if they end up in water and they are deposited and compacted and cemented, they will become sedimentary rock. The same thing is true with a metamorphic rock. If there's a metamorphic rock that gets weathered and eroded and becomes sediment, which is deposited and compacted or cemented, that also would turn into a sedimentary rock. So the Wedkeke processes are all listed on your rock cycle chart. You don't need to memorize them, but you do need to know what happens with each step. So here's a picture of some sediments that have been deposited. If they were to be compacted and cemented, they would solidify and become a sedimentary rock, such as that one. The same thing with the rocks that I'm standing on in this picture. If these round stones become compacted and cemented, they would turn into a sedimentary rock. And here you can see rocks that have been compacted and cemented. You can see the large clasts, the large grains that make up that rock. So let's go through the 5 clastic rocks that are listed on your reference table. You'll notice that the thing that makes them different from each other, or the way that we classify them, is by their grain size. If a rock has large grains, grains that are pebbles or cobbles or boulders, if the particles are round, we would call the rock a conglomerate. So here is a piece of a conglomerate. You can see these large rounded particles in the rock. These were some conglomerates that I took a picture of while I was hiking one day. And again, you can see these large clasts, these large grains inside the bigger boulder. Here's a conglomerate that was found in a building in Italy, where they actually used the conglomerate to build these columns. And again, you can see the clasts, you can see these large rounded grains. Now, if there are large pieces that are not rounded, but are sharp and angular with jagged edges, then that rock is called a breccia. So again, conglomerates have rounded fragments, breccias have angular fragments. Now, if a rock has smaller pieces, let's say that the individual grains range from 0.06 of a centimeter to 0.2 of a centimeter, we would call that rock sandstone. Sandstone is pretty easy to identify because when you feel it, it feels pretty coarse. It feels rough like sandpaper. So these arches were made out of sandstone. Now that tells us a lot about the Earth's history, because if this is a desert currently, we know that at some point it was probably underwater, and this was a beach, and all of this sand was deposited. This was taken on the side of a highway in Connecticut, and again, you can see how high this sandstone is, telling us a lot about the past history of this environment. Sandstone's becoming quite popular for flooring tiles, and you can see it comes in many different colors, as there are different color sands all over the Earth. A lot of buildings in Manhattan, like the Museum of Natural History, are actually built out of sandstone. Now, if the grains are smaller than sand, they would be called silt or clay, and depending on the size of the particles. Silt and clay, you're not going to see the actual grains because they are microscopic. Okay? But what we'll find is that they are very fine grained, very smooth, and very compact, and shale can split easily. So those are our clastic rocks, which are inorganic, not living, coming from things that are on the land. And again, they are classified based on their grain size. This is the key to this whole top section. Now let's take a look at the rocks that are formed chemically. There are 2 processes that can form these chemical rocks. And you'll notice if you look at the bottom part of your chart, there is a texture that is described as being crystalline or crystals. The 2 processes that make these rocks are called precipitation and evaporation. And again, you'll see those words on your reference table. Okay? Precipitates and evaporates. And over here we see the word precipitates. The process where evaporates form has to do with evaporation. So oftentimes water will have minerals dissolved in it. Water, we know, will evaporate when it gets heated up by the sun. Minerals that are in it cannot evaporate, so they are left behind. They are deposited. And when they're left behind, they turn into rock. Some of you may have noticed around some of the faucets in your house, especially the bathtub faucets, you might notice a greenish or bluish or sometimes an orangish kind of crust that forms around the faucet. Those are actually minerals that are in your water that have been deposited on the faucet. So let's look at some rocks that form this way. Actually, let's talk about precipitates first. You know the word precipitation and you think of rain falling or snow falling. Precipitation, there's also another process. And what happens is that when there's water that is very saturated, very filled with minerals in it, what can happen is the minerals can build up and they become too heavy to stay suspended in the water. So they basically fall out of the water and they end up on the bottom. You might have seen this when you've made a cup of hot tea. If you've mixed in sugar, as the tea cools down, the sugar crystals will actually fall out of the tea and end up at the bottom of your glass. So that is a process called precipitation. So let's start by looking at a rock called rock salt, which comes from the mineral halite. So here's halite, and halite is dissolved in the world's oceans, right? The oceans have salt water. And so when the water evaporates, the halite gets left behind in the form of rock salt. This picture was taken at the Dead Sea, which we know is the saltiest body of water on Earth. And all along the shore of it, you can actually see these salt crystals, which were created when the water evaporated and the salt was left behind. All of this white, this is all rock salt. Again, close up of this rock, you can see little tiny salt crystals. Now the next rock that's listed is rock gypsum, which is made of the mineral gypsum. So here's the actual mineral, and if this is in water and it either the water evaporates and leaves behind the rock, or so much gypsum is in the water that it falls to the bottom, we get rock gypsum. Dolostone forms in the same way, forms from the mineral called dolomite. Now the final crystalline rock on your chart is actually listed in this category that can have two textures, and that is limestone. The limestone cliffs that you're seeing here, they were formed by precipitation. So basically enough limestone was in the water that it clumped together and it fell to the bottom and it was deposited there. These rocks are also limestone. The pyramids in Egypt are made out of limestone, as are many of the rocks in Jerusalem. This is the Western Wall. It's made of limestone. Now, the final type of sedimentary rock are the ones that are formed organically, which basically means from living things. And we describe their texture as being bioclastic. So bio means life, clastic means pieces, so pieces of life, pieces of living things. And the two rocks we have that form this way are limestone, which mainly has calcite in it, and bituminous coal, which is made of carbon. So limestone, when it's formed this way, is formed from cemented shell fragments that are clumped together. So here's a piece of limestone that has a bioclastic texture. You can see all the shells. Some of them are quite large. And so basically creatures die and their shells clump together and they turn into limestone. Here's another piece of limestone. We can see fossils of shells. So this would have a bioclastic texture, pieces of living things. And then the final rock on here is bituminous coal, which is basically formed from dead plant remains, which have been compacted over millions and millions of years. So much pressure has basically turned the plants into coal. So again, it has a bioclastic texture. So those are all of your sedimentary rocks. We'll spend the next couple of days looking at them. You're going to be making observations.
From this video, the author is just describing about how sedimentary rocks are classified in the field. In this is the main table column where you people can expect a 40 more question about this description of sedimentary rock identification with inorganic and organic material. Like inorganic means it is not having any life in the past and not in the present. It is been made by inorganic material. Here, in inorganic material, based on the texture, they have been classifying the sedimentary rocks. If the sedimentary rocks are having a more larger of size of crystals which have been, while cementation, there are possibility of accumulating more number of crystals. If the sizes are more based on grain size, if sizes are more, it will be of pebble, cobbles and boulders embedded in sand, silt and of clay. And if it is having a round, see here, if it is having a round, then it is conglomerate. If it is having an angular fragment, then like this, it is ratio of then sand. It is of having a size range of 0.006 to zero point 0.2 centimeter, where the components present in the sandstone, that is in sandstone, if it is fine to coarse, it is sandstone, and silt, it is having a centimeter range of 0.0004 to 0.006 centimeter, having a very fine grain, then it comes under siltstone. And last one in clastic sediment is clay, where it's having less than 0.0004 centimeter, where it is more compact and it can be easily split. Then we say it as slate. These are the inorganically land derived sedimentary rocks which you can see in our land, and some part after the transportation it can be settled in the sea also. These type of things in Tamil Nadu you can see a maximum number in the region where previously the land or occurred, and now also it can be seen. Next one, that is chemically or organically formed. Here they have been classifying that into three. One is crystalline, another one is crystalline or bioclastic, third one is bioclastic. If it have been formed like grain size is fine to coarse crystal, if and with that also having a subdivision allied composition, in the composition suppose it is present allied, then it will be of rock salt. If it is gypsum and it is having some, like before that I want to explain here there are two methods. One is precipitation and evaporate. Evaporate means if you take a glass of water, pure water, you add some salt or any other undissolvable material in it, and you just place the glass bottle outside your house for a prolonged of period, then due to evaporation water will get evaporated. These sediments which you have inserted in it mixed with the water, it will be settled at the bottom. Likewise, if it have allied composition, it will be having rock salt of allied, and if it is having a gypsum composition, it will be having rock gypsum. If it have been dissolved in water with the dolomite, then it will convert into dolostone. Then here, whether microscopic to very coarse the grain sizes occur, it will be having a biological concept of calcite or carbon. Then it will be categorized as limestone and bituminous coal. Bituminous coal means it will be having the dead plant decaying of all material which have been preserved. So here we have seen about this sedimentary rock identification based on the inorganic and organic by the way of texture, grain size, and composition. So today we have seen about the sedimentary rock classification based on the grain size, texture, composition, and what are the process involved in it. We have seen today, and furthermore,
In this
one
video,
video
we're going to
is
be
there
talking about
where you're
sedimentary
going to
rocks.
see about the
Please make sure to have your rocks flowchart ready, as we're going to be filling in another portion of
then
it
you
today.
can able to see all those. Now in a manner, how we going to see all those? Whether I have shared my screen or not, I think I have not shared my screen. Now
Not sure.
I'm just
No,
share,
sir. No, no,
I'm
no.
just sharing the screen. You just watch it, and we'll be having a question answer session, and then we can hide up the session of today's class. Okay, I'll just share the screen. You people just watch it.
Tree rocks. Please make sure to have your rocks flowchart ready, as we're going to be filling in another portion of it today. Let's get started. Of course, as I mentioned, we're talking about sedimentary rocks, the second variety of rocks in our rocks chapter. Please recall that rocks are classified according to the way in which they formed. So, for example, igneous rocks form from the cooling and solidification of magma or lava. Now, sedimentary rocks form in an entirely different way, which I'd like to describe now. The general way in which most sedimentary rocks form is from the compaction and cementation of sediments. Now, there are some words there that we need to talk about. First off, compaction means what you might think: compacting, squeezing together. Cementation means gluing or cementing, sticking together sediments. But that brings up yet another question. So if these rocks are formed from the compaction and cementation, the squeezing and gluing of sediments, well, what exactly are sediments then? Well, sediments are the fragments, the little bits of rock that have been broken down as a result of a process known as weathering. Weathering includes wind and ice, running water, etc. So imagine you have a big boulder sitting in your backyard. Well, if you were to somehow magically leave the earth and come back 10,000 years from now, that boulder might look very different. As a result of years of wind blowing against it and ice cracking it apart and water flowing over its surface, it will have broken down into smaller and smaller pieces. That's what sediments are, the small fragments that result from the weathering of rock. Sediments, interestingly, are classified according to their size. So we actually have 6 categories of sediment sizes, the smallest being clay, then silt, then sand, then pebbles, cobbles, and boulders being the largest. So you've heard the term sand before. Now you know that it actually just refers to a size of particle, not a specific material. If you want to know the specific sizes that make sediments fall into any of these categories, you can find that information on page 6 of your Earth Science reference tables. You can ignore the graph portion of this chart as we haven't learned about it yet. However, I'd like you to pay attention to the names of the sediment sizes on the right-hand side that I've highlighted in green. They will tell you how big each sediment is. So let's use sand as an example. For a sediment to be considered sand-sized, it would have to be between 0.006 centimeters and 0.2 centimeters. Anything bigger would be a different type, as would anything smaller. Another example, boulders are considered any sediment that are larger than 25.6 centimeters in size. Now, let's talk about the first type of sedimentary rock, because there really are 3 types. The first type of sedimentary rock is called a clastic sedimentary rock. Now, a clast is actually just a fancy word for a sediment. So these are actually the types that we have already been discussing. These clastic sedimentary rocks form from compacted sediments, and these are generally classified according to their size. Let's take a look at the sedimentary rocks reference table. Now, the clastic rocks are the ones that are on the top half. They're also referred to as the inorganic, because they don't involve any living materials, and land-derived, meaning they come from the land. They come from the rock that makes up the land. Now, if you'll notice under grain size, you can see the different size sediments that make up each of the rocks. Composition tells you what minerals you would expect to see. Comments are just important information. And then, of course, you have the names of the rocks and something called the map symbol, which we'll be using more later in the year. So let's take a look at some of these clastic sedimentary rocks, beginning with the first one, conglomerate. Conglomerate is composed of all different size sediments or clasts compacted and cemented together. So you'll have big cobbles, pebbles, maybe even boulders, compacted with small sand, silt, and clay. Notice that the sediments in a conglomerate are rounded out, likely due to flowing water that ran over them sometime in the past. Very similar to a conglomerate is a breccia. Breccia too is made of all different sized sediments compacted and cemented together. The difference being the sediments in a breccia are not rounded. They are more angular, pointy, or jagged. Then we get to the sandstone. As you can imagine, sandstone is made of compacted sand grains. Siltstone, made of compacted silt. And shale, made of compacted clay particles. So those are your clastic sedimentary rocks. Compacted and cemented sediments. Now back to our chart. Let's look at another type. Let's actually look at the other 2 types. We have organic and crystalline sedimentary rocks. For the crystalline, we have things called evaporites and precipitates. And then for the organic, we have what we call biological matter rocks or bioclastic rocks. Let's talk about these, as they are a little bit more complex. First off, the crystalline rocks, seen here on the reference table. So these are under a column that says chemically or organically formed sedimentary rocks. So these are not necessarily from compacted sediments. In fact, the crystalline ones form in an entirely different way. So crystalline sedimentary rocks are known as evaporites or precipitates. And what that means is that they form as a result of some sort of chemical process. Let's take a look at some examples. This is probably the best example. This is rock salt. Now, rock salt forms from seawater, which of course has salt or halite dissolved in it. And when that water evaporates, the salt stays behind in the form of crystals. Those crystals are the rock salt. This is why it's called an evaporite. This is also why it's called crystalline, because it's crystals of salt that were left behind after evaporation occurred. We also get other rocks like rock gypsum and dolostone that form in similar ways. Just to mention the precipitate, this is a similar process. However, as the name implies, it does not involve evaporation like rock salt does. A precipitate forms when a water sample is completely filled with a dissolved mineral, so much so that the mineral falls out of being dissolved and crystallizes in the bottom of a body of water. To summarize, the crystalline rocks all involve some sort of chemical process, whether it's evaporation or precipitation. The result would be rock salt, rock gypsum, or dolostone. But what about these biological rocks, the bioclastic rocks? Now, these form from compacted organic material or organic matter. We already know some examples of these, which include coal, which forms from compacted plant remains, and then this, which is a variety of limestone called a coquina. And you'll notice this is made of compacted shells. Shells, of course, are made by sea creatures. This is organic material, and so being classified as a bioclastic rock because it's organic matter that's been compacted together. One more key note about sedimentary rocks is that they're the only type of rock that may contain fossils or evidence of past life. So if you see a rock with a fossil in it, you know automatically it must be a sedimentary rock. The reason being, the processes that involve the formation of igneous and metamorphic rocks involve a lot of heat and or pressure. And so these processes would destroy any fossils that existed. Therefore, the only type of rocks that really commonly contain fossils are sedimentary rocks. We'll learn all about this in school. Thanks for listening.
Today, we have seen about the sedimentary rock formation, classification, how they are forming, and what are the types it may be formed. And we have seen about the table of identification of sedimentary rock in our field. Now we are just moving to the attendance session for today's class. After taking the attendance, I'm just asking you to about some people explain about today what we have seen in our class. And after that, I'm just closing the class. Now I'm just going to share my screen. The people just see the attendance and let me know whether you are present for today's session or not. I think today 2 people have absent for our class. Bhavindraj,
Present, sir.
Manikandan, Nitin, Annamalai,
Present, sir.
Jaykumar, Sedu Madhavan,
Present, sir.
Mukil, Murugavel, Murugavel, Praveen Prabha,
Present, sir.
Present, sir.
Anthony.
Present, sir.
Okay, who is absent for today's class? Totally, there are only 1 people have absent. I'm just finalizing the attendance. You can also take a snap of this one. Today, only Nitin have got absent. I'm sharing my screen. Now is question answer session. Seth Madhavan,
Yes, sir.
can you tell me about today in class what you have learned?
sedimentary rocks என்னன்னு பார்த்தோம் சார்.
Okay.
அதில் 3 main types of rocks:
What you
sedimentary,
want
metaphoric, igneous.
Hmm.
அப்புறம் sedimentary rocks வந்து ஃபார்மேஷன் 5 டைப்ஸ் இருக்குது சார். வெதரிங், எரோஷன், டெபாசிஷன், கம்பாக்ஷன், லித்திகேஷன். அதில் வெதரிங்னா பிரேக்கிங் அப் டு ராக்ஸ் இன்டூ ஸ்மாலர் பீசஸாக அது வெதரிங் சார். எரோஷன்னா மூவ்மெண்ட் ஆர் டிரான்ஸ்போர்ஷன் ஆஃப் பீஸ் ஆஃப் ராக் பண்ணுறது எரோஷன்னா. டெபாசிஷன்னா பீஸ் ஆஃப் ராக்ஸ் கம் டு ரெஸ்ட் ஆன் மை சர்ஃபேஸ். காம்பாக்ஷன்னா கம்ப்ரஸிங் த ராக் டு வெதரா பண்ணுறது. லித்திஃபிகேஷன்னா டிசால்வ்டு மினரல்ஸ் அண்ட் கிறிஸ்டலைஸ் அண்ட் சிமெண்ட் ராக்ஸ் டுகெதர் பண்ணுறது லித்திஃபிகேஷன் சார். அப்புறம் ஸ்கீம் ஆஃப் செடிமெண்ட்ரி ராக்ஸ் ஐடென்டிஃபிகேஷன் இன்னும் அதில் இன்ஆர்கானிக் லேண்ட் செடிமெண்ட்ரி ராக்ஸு, கெமிக்கல் ஆர் ஆர்கானிக்கலி ஃபார்ம்டு செடிமெண்ட்ரி ராக்ஸ்னால் என்னென்னு பார்த்தோம் சார். அதில் வந்து பிளாஸ்டிக் ராக்ஸ் ஒன்று பார்த்தோம். அப்புறம் அதில் என்னென்ன ஃபார்மேஷன் நடக்குது, எப்படி ஃபார்ம் ஆகுது செடிமெண்ட்ரி ராக்ஸு அப்படின்னா என்னென்னு பார்த்தோம் சார். அப்புறம் ஸ்கீம் ஆஃப் செடிமெண்ட்ரி ராக்ல ஐடென்டிஃபிகேஷன் என்னென்னு பார்த்தோம். அதில் லேண்ட் டிரைவ்டு செடிமெண்ட்ரி ராக்ஸு, கெமிக்கல் ஆர் ஆர்கானிக்கலி செடிமெண்ட்ரி ஃபவுண்ட் ராக்ஸ் பார்த்தோம். ரெண்டாவது ஒன்று வந்து கிறிஸ்டலைன் ராக்ஸ் பார்த்தோம். அப்புறம் அதில் என்னென்ன ராக்ஸ், ஹேலைட்டு, ராக் சால்ட்டு, ஜிப்சம், ராக் ஜிப்சம்னா என்ன. அப்புறம் மூணாவது வந்து ஆர்கானிக் ஆர் பயோ பிளாஸ்டிக் ராக்ஸ் என்னென்னு பார்த்தோம். அப்புறம் லாஸ்ட் வீடியோவில் வந்து செடிமெண்ட்ரினா என்ன, அதோட ஃப்ளோ சார்ட் பார்த்தோம். செடிமெண்ட்ஸ் ஆர் ஃப்ராக்மெண்ட்ஸ் ஆஃப் ராக் தட் ஹேவ் பீன் broken டவுன் as a result of weathering பார்த்தோம். அப்புறம் செடிமெண்ட் எப்படி கிளாசிஃபைட் ஆகுது அக்கார்டிங் டு சைஸ், கிளே, ஸ்லிட், சாண்டு, பீபிள், கோபிள், பவுடர். அப்புறம் அதோட கிராஃப் பார்த்தோம் சார். அவ்வளோதான் சார்.
Today we are seeing this much of things, and I just wanted to people to see this video again. I will be uploading today evening. So just to see this video whenever you are free. Take a notes of this for your sediment classification, identification, and you can expect here 14 more question and 10 more question. Okay. Now I am just closing the session. You people can see this video at evening. Today evening I will upload, and we will be seeing you people on tomorrow class. And I hope you just